Okay, good afternoon, class. So at this point we are looking at, we are busy with geometry, correct? This is supposed to be our last lesson on geometry, dealing with similarity and congruency. But you guys have written a test on Friday that passed on geometry. So it was class test 3, term 2. People, this is how you get 24 marks. Not how you guys did. Alright, so we are told that MP is equal to PO. That's given to us. Then we are told that P1 is equal to P2. The question says, prove that triangle MPN is congruent to triangle OPN. To prove congruency is one of 4 cases. Side, 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 angle, side, like that hypotenuse side, angle, angle. 4 cases. So, in these 2 triangles, what can we say? In triangle MPN and triangle OPN. Okay. What can we say? MP is equal to? Why are you walking around? To go again to the toilet. Come. Put up, then down, up. Okay. MP is equal to POY given. Then P1 angle P1 is equal to P to Y given. PN common side. So therefore triangle MPN is congruent to triangle OPN. Why? Side, angle, side. Okay. In 1.2 the question is to show that MPON is a kite. There are 5 properties of a kite. Okay? 5 properties. So we prove one of those properties exists here. So if this is a kite, already the 2 adjacent sides are equal. Not so? So, we also know that let's take this off here. We also know that MN is equal to NO. Not so? So MN is equal to ON. Why? Because triangle MPN is congruent to triangle OPN. Can you see that, people? So therefore MPON is a kite. Why? Because two pairs of adjacent sides are equal. Two pairs of adjacent sides are equal. Okay? Any confusion there? If you had just gotten that right, you would have gotten 7.
So if you say MP is equal to CO, and that equation you mark to it.
Yes! This is how we mark. 4 marks, no? So it's 1, 2, 3. If those 3 are right, then you get this mark. 4. There are 3 marks here. 1 mark there. 1 mark there. Statement, reason. Reason mark. Because that is the statement coming from here. So you can't get the reason mark. Okay? Look at the next one. Here it says study the diagram and answer the following questions. First question. The first question is to prove that ABC is similar. Now, how do we prove similarity? We prove that the angles are the same, not so? Right, so what can we say about the angles here? So we're supposed to say in triangle ABC and triangle CDE. What can I say? A, BC and CDE. What can I say? What do we do to prove similarity, people? We prove that the angles are all the same. We prove that the two triangles are equiangular.
D is parallel to CD. B. CD.
How do we prove similarity? We prove that the angles are the same, not lines are parallel. So, see, this should also be a guide to you, man. You see A and C. Let's see A and C. Is angle A equal to angle C? Why? Alternate. Can you see that? So let's see. Angle A is equal to angle C. It's alternate angles with AB being parallel to CD. Right. Nope. Not the angle C. I'm trying to save space here because I'm writing over the diagram. So there we go. Angle A is equal to angle DCA. Why? It's alternate angles with AB being parallel to CD. Now angle B is equal to angle D. Angle B is equal to angle D. Can I link those two? No. So let's go to the other angle. Angle C and angle E. Angle C of the big triangle and angle E. Are those equal? Why? Alternate angles. So we can say, can we just say C? No. So it must be ACB or BCA. BCA is equal to angle DEC. Why? Alternate angles with DE being parallel to CB. Now automatically this one has to be equal. So angle D has to be equal to angle B. Why? The third angle in triangle. You will agree with that? The third angle in a triangle. So therefore, triangle ABC is similar to triangle CDE. Why? Angle, angle, angle. Okay? You will understand? Hmm? No. Let's see now. The next question in 2.2 says, find the length of AC. As I told you before, after similarity question is rest assured it's going to be a distance question. You do the length of this thing. So AC, so before we do anything, we first set up our ratios. So it's AC over CD, CE equals BC over DE equals BC and DC, BC and CD is the same. We got AB, no? No, AB over CD. Why? Because triangle ABC is congruent to triangle CD. Similar. Or we could have said sides are in proportion. Okay. Or we could have said the sides are in proportion. So what's the length of AC? Unknown. Okay, and that's what they want you to calculate. AC over CE, 3.2 equals BC, 7.5 over DE, which is 5, equals AB, unknown, over CD, 4. But what do they want you to calculate? AC. So you all agree I should be able to use that. So you cross multiply that. So that is going to give us, pull this down here. That will give us 5 times AC, 5 AC is equal to 7.5 times 3.2. So AC is equal to, you divide by 5 both sides. So AC is equal to 7.5 times 3.2 over 5. Now you guys didn't have a calculator, no? So I would have accepted that there and gave you full marks there at that point. Okay, but if you had option of working it out to the calculator, it's 24 over 5 or 4.8. Okay. And this length isn't given in any units there, so you just say 4.8 units. Okay. The last question was interesting. It says determine the values of x. Determine the value of x in the diagram below. Show all your work. I'll just pull this up here. It's number 3. So if you look at what we have here. Okay, go to 3. We have lengths that are equal here. Not so. So which means to say this angle C is equal to this angle here. Not so. Why? Because when our angles opposite, equal sides. Not so. Angles opposite, equal sides. Then these lines are parallel. So corresponding angles are equal. Not so. So if you look at how many marks are allocated for the sum, there's 8 marks. Okay. So there of course has to go some calculation into it. But we can't set up an equation straight away from this information given in pursuit of solving for x. Okay. So let's see what do we have and what can be calculated. We have 20 degrees here and we have 44 degrees here. So what could have been calculated at this point? Which other angle can be calculated? Sorry? Angle BDA. Yeah? This angle here. So we say A DB plus 20 degrees plus 44 equals 180. Why? Some triangles, and this is triangle BDA. So ADB is equal to 180 minus 20 is 160 minus 44 is 160. So this angle is 116 here. Okay. Then we see that this angle here and that angle is the same. Why? Angles opposite equal sides. Not so? So we first say that angle C is equal to DBC. Why? Angles opposite equal sides. Alright. Now angle C plus this angle here is equal to 116. Not so? This is the exterior angle of triangles equal to sum of two interior opposite. So what I'm going to do is I'm going to calculate C only. Okay? Or this angle here, because I need this angle. So we can say that D BC plus angle C, which is also DBC. Why? Because the two angles are equal. The sum of those two angles is equal to 116. Why? So that's exterior angle of triangle and it's triangle BDC. Divided by 2. So DBC is equal to 5 carry over 58 degrees. That is 58 degrees and that angle is 58 degrees. Okay? So what do you see now? Corresponding angles. There we go. That angle is equal to that. So in other words, x is equal to 20 plus 58 degrees. Why? It's corresponding angles with ED being parallel to DA. So x is equal to 0. That's how we got 8 marks for that sum. Okay. It's also important that the mark allocation guides you to the amount of work that will go into the sum. Okay. So some of you just wrote one line and the reason. Do you think that would warrant 8 marks? Okay, so something to think about, okay. Then I gave you more similarity to do, ne? Not grade 10 yet, ne? From the workbook that we're working from, you had to do page 29 to 33, ne? Yeah, 33. So let's start similarity. To prove similarity, we prove that either one of two things. We prove that the angles are the same, or equiangular. The two triangles are equiangular, or the sides are in proportion. Okay. Mistake, no? So either equiangular or the sides are in proportion. One of the two. Okay. For your level, we only deal with equiangular. Okay. So in A it says show the following triangles are similar. Okay. So I'm only going to go with the fact that's equal angles. Okay. So what can we say here? In triangle ABC and triangle DEF. What can we say? Angle A is equal to angle D, which is y given. Angle B equal to angle E, which is equal to 55y. Last one. Angle C is equal to angle F, which is equal to, we could have worked that out. It's going to be 90. 40 is 100, so it's 80 and 80. Not so? 80, which is the third angle in triangle. Does it make sense, people? You see that? It's 45, 50, and it must be 80. 45, 50, and 80. You guys understand? Right. So enough to conclude congruency. So you can say, therefore, triangle ABC is similar to triangle DEF. Why? Angle B. Okay. Any confusion there? What are you doing? Why are you not writing it down?
Because I'm fast.
Too fast. Watch the video later. Get this, watch the video, get all the stuff. Now you're sitting on the phone taking photos when not ready. Now everybody take out photos, then take out the board, selfie, then a different level again. Some TikTok videos. Okay. So you guys understand? Alright, let's go to the next one. Let's look at C. What can we say here? In triangle is PQR and triangle LMN. What can we say? Angle R, yes? Y? Given. Right, next. Angle P, which is equal to 44 degrees. Why? Given. Last one. Angle Q equal to angle MY. Third angle in triangle. So therefore, triangle PQR is similar to triangle LMN. Why? Angle. Okay. Take a photo. It's fine. Okay. Next one. Page 30. Now that is proving that the sides are in proportion. Okay. I'm not going to do that one. Let's do B. So this is that one method I said we're not going to do for now. Okay. We're only going to prove that angles are equal. Because you guys are still grade 9, man. You're still like, babies. Yeah? Babies still sleep this time of the day and stuff. Yeah. So, let's do this. Will you see two triangles? I also want to sleep this time. So it's in triangle A, BC, yes? And triangle AD. You all see that? What can we say? E1 yes, D1 equal to B. Why? Given. Another one. If the lines are parallel, they will correspond. E1 is equal to C. Why? Given. One more. A is a common angle. Can you see that, people? Or I could have said A is the third angle in the triangle. Okay, anyone would have been correct. So therefore triangle ABC is similar to triangle ABC ADE. Why? Angle. It's either that or that. It's the same. People, you're not going to get this angle mark, the fourth mark. You're never going to get if you made a mistake. Okay, that must be in order to draw the conclusion out of it. That's again the one where the sides are in proportion. The next one. Yeah, here's a good one. So here we've got two triangles. In triangle A CE. This is right, this meter. ACE and triangle BCD. Right, what can we say? Yes. Angle A is equal to angle B1, which is equal to 90 degrees. Why? Given. Van Boom, what you busy with? You're writing this? I can see you writing, but at the rate you're going at, I don't think you're writing geometry. Am I lying to myself? Okay. So we're going to check now if you told me I was lying. So whatever lovely to you busy with, put it away. Whatever you're busy with. Okay, so angle A is equal to B1 is equal to 90. Why? Given. Yes. B1? Why? No. C is a common angle. Can you see it? C is in this triangle and in that triangle. So angle C is a common angle. You see that, people? Angle C? Common angle. Angle E is equal to angle D1. Why? The third angle in triangle. Remember, for similarity, we're only proving that the angles are equal. Nothing to do with the side. Can't go side, angle, side. No. The third angle in triangle. So therefore, triangle ACE is similar to triangle BCD. Why? Angle, angle, angle. Okay. Right, let's look at this one here. So in triangle ABC, who can give me the right order here? A, B, C. A, B, D. No. A? So you're saying A? DC? A, B, C? A, B, C, yes? B? C, D. Okay, so let me just write down what you're saying. D, B, C, like that. Let's see. A, you see this big triangle is one dot in this angle. Here's the one dot. So it must be B.
So is it B?
Yes, we did say B.
Oh, you said B, C, okay. Let's go. B, CD. Right, let's go. A with B is B, which is 90, with D is no. Can you see here? A, B, C. The B is 90. You're going with D1 being 90. So the order is B, D, C. B, D, C. That's the correct order. Okay. So, what can we say? B, A is equal to angle B2. Why? Given. Right. Then, angle C, this is common. The common angle. Okay? Therefore, D1
3, sir.
yeah, D1 is equal to angle B, ABC. No? This angle here is equal to this angle here.
Yes. So the direction is
Why? The third angle in triangle. Or you could have said that D1 is 90 angles on the straight line, and then say D1 is equal to ABC, which is equal to 90.
So you couldn't say B1 is equal to
No. So this is D2 is 90, which is resulting in D1 being 90. You're talking of B1. B1 is a combination of B1 and 2, which forms 90. Alright, so we say therefore, triangle ABC is similar to triangle BDC. Why? Angle, angle. So here's a lot of similarity, 3 dealing with sides. So this is basically where we're going to stop today. And this brings us to the end of this section of work. The only part of geometry that is left is our Pythagoras that we need to do sometime. Okay?
Yes.
Sorry? Sums. They give you more other sums also. Pythagoras. I don't know what you're talking about. Oh, we're going to let us do some algebra. I can do a couple of equations before the end of the lesson today. Okay. So I'll stop this video.